Hey physics. Okay, here's activity 3. Does the particle model also work for gases? This was originally called Determining the Mass of Air, but this is a much more fitting title for it. Um, so, okay, so in the last experiment we explored the particle model of matter in terms of liquids and ethanol. This investigation is looking at gases as, do they work for gases? Is that true? So the first thing we need to define there is our gases matter. And I want to be a little bit clear here about the difference between air and gases and matter and all of that stuff, because I was noticing as I was reading the first few responses of this that that there's not like a clear definition of that for you guys, for some people. So air is like the general thing, like talking about all the stuff that we breathe in that just happens to be there, you know, specifically. When we're talking about gases, that's like the name for the form of matter that it's in. So we can have water vapor as a gas, as a liquid, or a solid, but gas is just the name of that phase of matter, okay? And so then matter is defined as anything that has mass and takes up space. So the first thing we wanted to define here is our gases matter. And yes, they are matter, because as you can see with this balloon, they do take up space and they do have mass. The reason why this balloon can float like this is because the gas particles inside of the balloon are heated up by the like a little fire that's right there, and that means that that the gas inside of that balloon has less mass than the gas around it, so it allows it to float up a little bit. So then we had this question about this picture shows how the closed syringe was stretched to increase the volume of the air inside of it, and then pinned with a nail to hold it like that. The open syringe was open to the same volume that the closed syringe was stretched to. So we have an open syringe. Let me show you this with some actual syringe. Okay, so here's what we have here. We have a syringe that has been opened. So we have a syringe, first of all. Hold on a second. Goodness gracious. Okay, so now I've got it. So we have this syringe that was stoppered, and it was opened up so that there's actually not very many particles of air in here. And what we would do for this question is we would weigh this syringe versus this syringe, which I have opened to the same volume, about 50 milliliters, or 50 cc's, cubic centimeters, sorry. Okay. So this one has very few particles of air in it, and this one is full of particles of air in it, okay? So which one is going to have more mass? So when you think about it that way, right, the one that has more particles of air is going to have more mass, right? So look closely at this one, because you'll notice this is not a multiple choice one. This is, you can select as many as makes sense. So if you look closely, actually every single one of those makes sense. There's fewer gas particles in the closed syringe. There's more gas particles in the open syringe. The ones in the closed syringe, this one, are farther apart because there's only a couple of them, and the ones in the open syringe are closer together because they're bouncing around like they normally would. Okay? So then here we have this syringe that has a stopper on it, and it's fully pushed in. It's as far down as it can go. Was it difficult to pull the plunger out? Yeah, it totally was, because the air particles in there want to be a certain distance from each other, and when they're not, it creates a force that makes it difficult to pull that plunger out. So what happens when I opened the syringe after having it stretched and pinned? Okay, so here's my one that is open, stretched and pinned. Okay, so listen to what happens here. Oh, you couldn't hear it that time. Probably because I've opened it and closed it a couple times now. But you would hear something like, psst, and that's the air that's rushing into the syringe there. The other thing that happens is that it becomes really easy to move the plunger, and except for that this one has a nail in it. Air fills the spaces in the syringe, and the plunger stays put, so I didn't have to pin it. So again, you want to read these questions really carefully, because this is one where you can select all of them, and you should select all of them, because those are all things that happen there. So now this is an important thing, and this is another one that is kind of summing up not just this one activity, but it also sums up like the entire investigation. So you can take your time and really think about this one. We're looking for a claim, evidence, and reasoning, asking the question, what is in between the particles of air? Okay, so we've kind of gotten this idea that we're looking at particles and not this continuous model of matter for a couple of reasons. If we had a continuous model of matter, then everything, all those particles would be the same size, and there'd be no space between them, right? They would be like just kind of like a mass, like what we can see when we see water. It looks like just like a mass of stuff, right? But we really know that whether it's liquid, solid, or mass, everything is made out of particles. In solids, those particles are really rigidly stuck together in certain ways, actually by things that are called hydrogen bonds that I'm really excited to tell you about soon. Those hold them together very rigidly. In liquids, we have hydrogen bonds that hold a little bit more loosely because of the way that the atoms' electrons are arranged. Yeah, we can talk more about that later. I'll talk more about with MSA about it for sure, but I'll try to tell you guys all about it a bit. But then with gases, what happens is that those atoms like to pair up together, and they're very stable. They don't have a lot of interaction with each other. And so they actually like to move a lot, and that energy of the movement is stronger than any kind of like electrical charge between them that would hold them together. So, okay, so back to this claim, evidence, and reasoning. That was kind of just like a tangent, because I want to give you guys an idea of why gases act that way, and why liquids act that way, and why solids act that way. It's the electrical charges between the particles in the molecules, between the atoms in the molecules. It's a whole thing. We'll get there. So the claim here, what is between the particles of air? What is between particles of anything? There's empty space between the particles. And we know this for two reasons. Because we saw that ethanol and water molecules fit together in a certain way, like rocks and sand, where there's space in between the ethanol molecules and the water molecules filter in there. We also saw that air, which is made of particles, can be compressed. So there must be space between those air particles if they can be compressed, right? So claim, there's empty space between the particles. Evidence, water molecules can fit in between ethanol molecules, and air particles can be compressed. And the reasoning is that we know that smaller particles can fit in between bigger ones, and we also know that if things can be compressed, they must not be taking up that whole space. Okay, I hope that helps. We'll see you soon.